Hey everyone, I'm Emmanuel. I'm just a member of OWASP Top 10 for LLM Applications. A little bit of my background. Can I use it?
Yeah, go
Yeah,
for it.
just okay. So, what is the plan for us? Ads will cover what the hell is OWASP and some threat modeling and emerging trends and threats in the wild. And I'll be discussing something a little different. So you get a complimentary talk, some different perspectives, as AI and LLMs are a very vast subject. We're not going to cover everything, obviously, but we try to bring something that's going to be of a value for you tonight. So I'll be discussing the security and governance checklist or data gathering methodology, which we've been working since last year. A bit of a high level training in CISO decision making. So myself, I'm a member also of the chapter. It's the first event that I'm coming. I'm a new immigrant to Canada. My background is Italian, Brazilian, and I've been in Canada about 7 years now. I like to practice Brazilian Jiu-Jitsu as physical security is important, right? So I gotta know how to defend myself, and I also like some adventurous sports on my free time. So, a bit of an overview of OWASP Top 10 for LLM apps. So, since beginning, I think it's March last year, Steve, the project lead, started the project, and some entries were entered, and we discussed uh, the relevance of each one. And there was an open vote. The most relevant ones were voted, and we came up with the list of the top 10. AI field is evolving, and the threat landscape with AI is constantly moving and developing, and always something new is coming up. And our group, it's such a diverse group. So the beauty is this diversity and seniority and the different places that we are in the globe bring different perspectives for us through the LLM AI environment that we are in. Why is it important? Data gathering, and as I said, Scott did a research about how much is being talked about the OWASP top 10 around the companies and media around the world. And he found out that our group has contributed about 60% in the talks that are in congresses and in CISOs and director discussions. So it shows it's such important topic to be discussing, and it's a hard one too, because as we all know, security, it's impossible to exhaust all possibilities and everything that we're going to find. And with AI, it's even more difficult and wilder. So our group, just a bit of an overview. So there's 142 contributors as of June. There's 90 companies represented. We have all of those listed there. We're gonna provide the um, slides for you guys as well. And we have about 1,200 people that are participating into the project. Um, so that being said, why do we need to worry about LLM security? So it's in the news. We all saw what happened with Air Canada recently, where the chatbot provided a wrong information and they had to pay. So it's starting to cost quite a bit of money to companies. So when it comes to the pocket, then that's where everyone's going to pay attention. And when it comes to AI and LLM, the threat landscape it's evolving, and as Elon says, we need to be proactive. Even being proactive, it's gonna be hard because there's always 0 days or something that goes missing or overviewed and cannot be predicted. So what is our job here is try to exhaust most of the possibilities to safeguard the organizations we work, and the public as well, because we need to also serve end result, which is what's the money the company is making using AI. So on the threat landscape, we have the companies that are not using AI, so that's a big disadvantage. We have the companies that are using AI, and then how are they training their people? How is everything evolving internally to safeguard and prepare? Is everyone aware how to use and the risks that are posed? So then Steve did a bit of research just to know the audience that we're treating among the project. So the charter was to direct and help developers that were developing LLMs and those systems. But to our surprise, we saw that security researchers and security engineers were a vast majority, and some CISOs trying to educate themselves with those risks that were posed. And here are some of the expert ideas that are being considered to our version 2 now. So the project now it's on version 1.1, which adds is our tech lead. He's leading the charge. I'm the boring guy. He's the fun guy. He's gonna bring some really nice information for you here. But those are some considerations that the public voted that are important for our group to consider when drafting the ideas that we're doing. We are connecting with some other organizations and bodies. So we are connected with NIST and with MITRE, especially MITRE Atlas, which does everything related to machine learning, which it's where we find the vulnerabilities on our top 10. Uh, we are also open for voting new entries. So if anyone here has a great idea, think, oh, your list is so outdated, it needs something new, we have new entries coming up, and they will be voted and filtered until we come up to the new version 2 top 10. Our security and governance checklist. This checklist was developed by Sandy Dunn, one of our core team members, and I've been a bit of a contributor with her. Just giving a bit of overview to the checklist to you guys. So the checklist was really, really serious, and for that reason, it was mentioned into a document NSA, CISA, and the UK government, Canadian government, New Zealand, and all of these institutions came together with how to deploy AI system security. So they reference our checklist as some of the best practices for the companies to implement when deploying the LLM applications within their companies. What we found when creating this checklist is the importance for regular audits and data privacy protection. So that's paramount. We, as security professionals, we all know if our data, which is the essence of a large language model, is not protected, then we are in big problems. Model security, because there's risks that are posed when we are using AI systems, and there are risks to the AI systems. So understanding the processes, the systems, and the technology that are used, it's very important when considering what the risk appetite will be used dealing and deploying those systems. Compliance regulations, um, HIPAA, GDPR, and California laws, all of those need to be considered and analyzed when deploying those systems. Encryption and secure storage, all the best practices that we have needs to be considered. And also, if we throw a little bit of salt into the mix, how about when quantum computing comes? So that's going to be even more challenging. The document can be found on that link. When you guys access the slide deck, you see it over there. Data gathering methodology. So what are we doing? From my end, leading the data gathering methodology, my job is to create a data set that will support the entries that will be voted. So up until now, we created a data set and a body of knowledge to support the entries that we have it now. Uh, it's all listed on our website. You guys can find the information there. Um, by doing that exercise, we scraped some data of academic papers that are related to the actual top 10 that we have now. Uh, Also mapped the top 10 to 13 different frameworks. The most important ones, CIS, MITRE Atlas, Stride, and so on, because different companies and different industries will use different approaches. So, as OWASP is an open source, we don't know who is going to be using that information. So, we try to be as comprehensive as possible to be useful for the community. Uh, Now we are open for call for action. So we have two templates, one CVS and one JSON, that will just to help us normalize the data that we is going to be receiving. So any company out there that are eager to share some of their findings with us, we will be using that to back up with data all the entries that will be voted. Um, how about the importance of data quality and integrity? So data is the lifeblood of a LLM. If the data is corrupted or if the code is not in line with the data, if you have bias and there's many implications that will play a part when building the the LLM models. Some of the best practices for or data collection. We have techniques for handling missing data and normalizing and standardizing. So some of this data, it needs to have an effect, 0 or 1, and there's different methodologies. Different companies, depending on how they're gonna approach their risk appetite and exposure, they're gonna be using some of these normalizations. They need to also understand, once you deploy the large language model, the training data, it's all done. If an error occur when you are training the data, that's where a lot of vulnerabilities happen. Once the model is deployed, you can have errors by the use, but on the training data, it's going to be very important to normalize and create validation for it. How do we ensure this data quality? Um, we ensure by understanding what data is missing, some imputation methods. So if something is missing, how we correct that, how we can use synthetic data to also make sure the system is working properly. Avoiding biased data sources as well. So some of this training data are using libraries, and it's very important to check the integrity of the data used when training the models. There are some techniques for data validation and to check everything that is missing and everything that is in line that will create an impact. So we have statistical and computational bias, human bias, and also systematic bias. When training the model, it's really important to consider all of those aspects to be as comprehensive as possible and avoid some errors. Um, on the data prep processing and cleaning, so imputation is one of the ways of creating, uh, filling the gaps on the missing data. Those are some of the tools that have been used. Pandas is the top one to some Python code to analyze and check how the data set is before deploying the model. And normalizing is standardizing. Also, checking with different frameworks that the company, if they work in Europe, they're going to be having to check also all of the data if it complies with the different laws and regulations of that area. So how we see high level training, overview training of the models. So there's the input layer and the output layer, and what's happened in between, which is the hidden layers. They will be impacted directly by the quality and how the completeness of the data that the model used to be trained. Once the model is deployed, to correct that, you have to retrain the model. These are some of the implications that large language models present. Once they're having issues with the data, new training is necessary to correct that. And there's the shift left on security. So what it means is once the model is deployed, then it's harder to fix. So being secure by design and incorporating security principles, uh, that's the different and the combating forces in organizations. They're always seeing the different objectives. The business leaders, they want the model, they want the project deployed, and the money coming in and acceptance by the public. And there's the developers, the security professionals that are defending sometimes a different perspective. So they're always trying to juggle and play that balance well. And how do we handle model drift, which is when the model starts to behave in an abnormal way and presenting new risks and performing incorrectly. So there are some techniques also that can be used for the model drift. For example, um, how we detect model drift by using some um, Python code that will analyze and cross-reference and using a team that is also cross-referencing different perspectives of the business. Because in different perspectives, they will check the different. Uh, sorry, I missed a little bit where I am here. So automating retraining pipelines, that's what I'm trying to communicate across. So we need to ensure the compliance with the different objectives of the business. And security professionals need to be able to communicate that to business leaders to make sure the model will behave in a normal way. And so what's the role of CISOs in AI security? Um, it's getting challenging, especially now with Apple communicating that they're gonna incorporate AI within their system. So for us, how about it only takes one flaw for credit cards, PII, and all of the good stuff to be leaked. And so sensitive information coming out of these models, it will create enormous repercussions.
But they are saying that it is going to be on the device. Like they are not sharing this in a cloud. So AI is gonna happen on the device, on the hardware. So it will be available when they release iOS 18.
Yeah, exactly, exactly.
So
But my,
minimum is iPhone 15, and
yes,
after that will be supported for
yeah, exactly.
They're not actually necessarily deploying an LLM as well. It's actually a smaller model which they're actually deploying on your device. If you're interested, one really cool thing to look at is like resource consumption. So if you can break a model to corrupt memory, and you could like, I don't know, like physically like start burning the MacBook, it's pretty cool. It's true.
Some key considerations. Um, it's preparing for incidents, right? So, how a company can defend itself, it's how ready they are in terms of if things go south, how we gonna correct course and how we gonna respond to that. And doing really aggressive red teaming, which ads will touch on his part of the talk. It's a very important part of getting CISOs ready to incident response within organizations using generative AI models. And some key considerations to secure AI implementations, encryption, um, getting all the systems in an architecture that it's complex most of the times, and role-based access controls. So this is going to be a really, really important one, and multi-factor authentication. All of these layers of security on the traditional security side, they still very relevant to large language models and how we behave and interact with AI systems. And hopefully, what we are doing with the OWASP Top 10 will help guide some of this information that will be available to CISOs to navigate the threat landscape that it's always evolving. There's always something new. Even in our group, we are such a diverse group, a big group. We have a hard time keeping up. We have a hard time because it's just so much going on. And in our bi-weekly meetings, everyone is invited, everyone can participate. We try to keep the pace, and it's good because everyone brings a different taste to the story. So governance, it plays a really big part in securing organizations using large language models. Uh, Establishing priorities and procedures, it's a key element when using the large language models. This is just a representation of creating a governance checklist incorporating law, value alignment, strategic alignment, risk and impact. What is the blast radius? How many clients will be affected? Um, Compliancy, transparency, and all the legal requirements as well that needs to be incorporating. OWASP web applications. Well, what I personally found is that the use of AI, it's getting so big that it's important for security professionals understand different nuances in the business to make sure they help guide developers and security professionals because this is a big task and it needs all hands on deck to make sure we are as safe as possible. And that's me. Now over to you. That's
Also, one
Thank
more
you,
question.
everyone. Absolutely.
How far we are from quantum computing?
Well, still far, I would say. And another discussion, ads is one of the entry leads for the actual top 10. So when I started engaging within the project, he wrote sensitive information disclosure. That's the entry. He was the lead, and I jumped in to discuss with him. I threw in about homomorphic encryption, which is encrypting data which is already encrypted. So that's going to be an issue when quantum computing is. As hardware and accessibility goes, they say maybe in the range of 5 to 10 years, depending on advancements of the technology and accessibility as well.
Okay, thank you.
Okay, thank you guys.
So I just have another
Yeah,
question.
absolutely.
Like when you say retrain an LLM or an AI,
Yeah.
are you starting from scratch or is there like a feedback loop when you?
Well, it will depend. It will depend because when you deploy a large language model, you can, depending on how robust your system is and the code is, you can verify what is missing or what is broken. Then you can replace that bit.
Right.
And in some cases, the damage is so large that it's easier to start from scratch.
Okay.
But this is not the autonomous, like this AI is, we are still not, like the general AI is still like 10 or 20 years ahead.
Well, generative AI is advancing as we speak. So,
But this is what we are feeding it.
Yeah.
And it's taking decision based on that, like basically sort of assistant to human. But the one like the Skynet or that kind of thing where it will take autonomously, it will take its own decision. Like that, I think it's still far ahead.
yeah, I think so too.
When we talk about model drift, right? So
Yeah.
can model drift happen because of overtraining of a data, and what are the steps?
Yeah, it can. It can because of the overtraining of the data, or the data starts to take too much performance of the model, and that can make the model go astray and starts performing in an odd manner.
So real-time tracking would be there. At what time you need to stop training the model? Something like that should is already in place, or like, I'm not
It depends on the organization. Different organizations will have a different playbook, and they're gonna follow what they have decided.
The algorithm behind it.
Exactly. Thank you.
Just to echo on that as well, another interesting topic is it's not very widely adopted, but data version control. So like SDLC, version control, GitHub, GitLab, whatever. In terms of like models, you talk about like artifacts, so you talk about like data and actual models. So it's not very widely adopted right now, but similar to kind of like a registry, then that could be a way of potentially rolling back. The really super interesting thing with like sensitive information disclosure or some kind of training data is that regression testing is like near to none because you don't know if it's a hallucination or that kind of stuff. Anyway, hello, I'm Mads. I started as a network engineer. I forked into network pen testing, then into kind of AppSec, and now I work at a foundation model company or NLP company, which is here, and we're Canadian, so cool. So a bit of ambiguity. NLP, natural language processing, is basically focused on the interaction between computers and humans in natural language to develop LLMs. LLMs are the driving force behind NLP, and are trained on huge data sets and designed to process and analyze text. Common examples are like generate text, text to speech, like predictive text on your cell phone, for example, right? So, do you mind if I actually put this on here?
Oh, yeah, if you can.
Because otherwise, yeah, I'm twisting. It's not really working. Cool. Thank you. So, in terms of LLM APIs or applications, right? Commonly, API endpoints are routes that handle requests with text-based payloads and data sent to the model. So like inputs, outputs, a bunch of HTTP request, stateless HTTP requests, normal like kind of REST API architecture. The difference is obviously with in terms of like a chatbot, it needs to maintain persistence. So you'll find like a lot of model companies will do different methodologies about maintaining that, like mainly in the form of things like conversation indexes and stuff like that. And also replaying prior web calls, but that's not very efficient in terms of architecture. LLM security, I feel, is actually quite a good, well-defined here, is the investigation of the failure of models, the conditions that lead to them, and then mitigations. So LLMs can fail to operate as expected or designed in a huge number of ways, which means they also can be insecure. Sensitive information disclosure, something like that, right? On top of that, they also run they're running software. Like a popular one is PyTorch, Pickle, which is a way to like serialize Python objects, and also software that can be insecure. So we introduced like a whole new concept of a supply chain when it comes to building machine learning, building models. You know, we kind of got like our machine learning development lifecycle as well as our traditional SDLC, and they definitely cross over. LLM security is broader than just things within existing security knowledge and existing LLM/NLP. It covers the intersection of security and NLP, but the union of everything about information security and natural language processing. So like Emmanuel was saying, it's much more about security in layers and security in the stack. I'll talk a bit in a second about the projects and how those correlate. So the OWASP Top 10 for LLM apps we started last year. LLMs are only like one concept of machine learning, but due to like the kind of revolutionary, sounds very corny, but the revolutionary kind of effect they had on the industry, it only made sense to kind of build a top 10 orchestrated around LLMs within applications, since it's the most adopted thing in the market today, right? Common things are like chatbots. It's not designed to be a rigorous framework. Ideally, you should be never using this as a stopgap. He's talking things that are more robust, maybe like the OWASP ASVS is still relevant here, as well as traditional network security, infrastructure, and cloud controls, right? The bit about the weird bit about the generative AI currently kind of details our movement within V2. So we got a really good amount of feedback from V1 and V1.1 and all that kind of stuff, but because our group has expanded so much now and the actual industry is kind of moving forward, it doesn't make sense for us to be so sandboxed, but also we don't want to kind of go like really deep into machine learning because that's not really like what the intention of the project was. When it first started out, a lot of people, it really bugged me because the domain we used to be called OWASP, used to call it Top 10 LLM. Whereas the word applications is so relevant because you're talking about like context of putting a model in an application, right? Versus just like an actual large language model. MLSecOps, which is kind of how I talked about the border and the overlap. So the top 10 for LLM AppSec guides stakeholders on what the most common risks and attack vectors are, similar to the OWASP API security top 10, as probably everyone's seen. What was I going to say? The one thing I actually really like about this is that this list was actually kind of here and correlate at the same time. There's a lot of other initiatives and communities that were kind of building at the same time as us and still are. It gives us a really good artifact where you can actually map like traditional OWASP API top 10 to actually machine learning lifecycle. I mean, some of them aren't very intuitive, but if we talk about things like, what was the one I used? Unrestricted model endpoints, which is traditional like broken access control, right? So kind of like literally just same thing, but different contexts and different examples and vulnerabilities and threats. Risk landscape is kind of the same, but they have their own context, or sometimes they may also overlap, right? Why am I talking about it? A good point is when we talk about threat modeling, or I'm a big fan of like building your own frameworks and your own methodologies and not just relying on one or multiple. So that's where I'm kind of like referencing a few here. This diagram is a work in progress, which is what I've been trying to work on predominantly for V2, which, like Emmanuel said, we've really been working on actually structuring other frameworks, things like CVs and CWEs, in line with our kind of list. Don't just want to give you guys like a list and be like, you should worry about this, and like this is like you should work out how to fix it. Kind of giving those like common enumeration techniques and weaknesses, and also like CVs, right? I don't know if anyone's seen like there are things like bug bounties now for machine learning development software, like Hunter by Protect AI is one. It's Hunter without an E. If anyone's into bug bounties. Actually, quick question, sorry. Show of hands, who's in like application security or software development? Machine learning engineers? Hey, Bill.
Security researchers.
GRC risk?
Developers.
Security operations. Yeah. Cool. Awesome. So basically what I'm showing, illustrating this example here is just like a very, very, very simple take on threat modeling and looking at a traditional LLM application, right? So this is like a generic diagram for the application. As you can see, I've labeled the trust boundary here, which is TB01. It's bilateral and it's obviously untrusted, bidirectional, as in the client input to the model. So this could be like public API endpoint or something like that. What I'm doing here is just literally marking LM10, which is model theft, which he talks about like stealing a model. This is relevant here, but what I've actually done, it's actually a bit small, sorry, is that I've actually mapped it to, I think it's like API 04 or something, which is actually like a lot of these mitigations you can actually do through traditional security or application security controls, things like rate limiting. So they kind of go hand in hand. Hence the reason for our project. So I put together like a very quick STRIDE table. For those who don't know, STRIDE is a threat modeling framework which is developed by Microsoft. It's one of many, like I'd say that, and Pasta is pretty good. So one of the vulnerabilities I've highlighted from that trust boundary that I showed earlier is model theft. So as we kind of talked about before, model training is extremely resource intensive, extremely therefore costly, cost of data, all the other things that comes across it. So what if an attacker or a competitor could steal a model with, at a cool.
Do you want it on?
That was it. That was intended. That was just set the atmosphere. I'm totally kidding. All good. Yeah. So it basically the same as many black box adversary attacks. It works by querying the model with samples and using the responses to basically forge a replicated model. Believe it or not, it's actually available. An effective remediation strategy, like I said, is insecure design of rate limiting, which is the OWASP API top 10 A04, which maps to LM top 10 model theft, right? So that's how they kind of coalesce together. But they do have some key differentiations. So each vulnerability has its own different and unique mitigations, even though they do still share that. In terms of model theft, like one form of extraction is the final layer of the model, which is often just a transpose of the first embedding layer. If the attacker can access the complete logic vector for arbitrary model prompts, then you basically make like a linear number of queries in the size of the embedding layer, and it runs in polynomial time. So this is not like deep dive comprehensive. It's just to kind of give like some examples of some of the vulnerabilities that are in the wild or cool stuff that I've seen or been able to replicate, which is pretty fun. So kind of like similar to CSRF, although we call this one cross plugin request forgery. So basically what we're looking at is a confused deputy attack where the adversary tricks an LLM into stealing private email information without the client knowing. So it's completely transparent. The confused deputy attack is triggered by an indirect prompt injection, which is a privilege escalation technique where a computer program that is tricked by another with fewer privileges into like elevating its own privileges, right?
The attacker hosts malicious instructions on the website in form of like hidden markdown. The victim actually browses that or summarizes that using, this is just an example here of like GPT. It actually reads, interprets the malicious instructions, which triggers an indirect prompt injection, takes control of the chatbot in terms of prompt injection, and then actually then follows the instructions, retrieves the email's PII, summarizes URL, encodes it, and uploads it to a remote arbitrary website, right? In terms of like mitigation, so the interesting thing is here, normally you would use something like CORS, which is cross-origin resource sharing, which would tackle CSRF. But obviously, CORS being based in the headers, right? This isn't relevant because you're looking at the actual API, then reaching out to another service. So really simple here, to be honest. Like human in the loop is probably the most effective mitigation at this point. And obviously, you know, just like classic security controls, like do not inherit explicit trust in third-party APIs, and establishing shared responsibility models between API providers. Very similar one here. This is same kind of deal. Data exfiltration in terms of cross-site scripting. So cross-site scripting or XSS, are types of attack injection where malicious scripts are injected into otherwise benign and trusted websites. So again, here what we're doing basically is summarizing a remote website during an interactive browsing session. So this time it's actually a different model, but literally the same kind of deal, right? We hide a hidden shell script in the form of indirect prompt injection, and then we can actually then just use the script basically informs the model to do action, take control, and then upload the content of the browsing session. So you can kind of imagine the abstraction of layers between the LLM application here of where there is faults within the app that are allowing that resource sharing between them. A mitigation here actually was interesting, as they actually used a CSP, which used to limit the image source directive, which is a content security policy is based on directives, to include only whitelisted domains owned by Bing themselves. So basically, unless the domain is owned by Bing, then markdown elements will not render in the browser. That's how they kind of, or at the time, this is how they trusted that. A CSP compatible browser will only execute scripts loading source files received from those allowed domains, ignoring all other scripts. So this random site. Yes, sir.
I was just curious, like, could you configure the LLM or have some controls within the model itself so that it doesn't execute code? And it just kind of like, if you're using it for generative AI purposes, it just uses it to, let's say, summarize something. Like, are there technical controls within the model itself that you can kind of configure?
Yeah, so there's like a few things. So like the first thing is like the preamble. So the preamble is like, you are a chatbot designed to like not harm humans and like do as I say and make me breakfast in bed, right? In terms of like, it's not executing code here. The difference is instead of actually like hosting just like hidden markdown, it's just another form of like a encoded text, which is interpreted within a web browser and sent back. So it's just literally hosted in the form of a shell script. But if you look at it, it's like basically, it's literally like a majority of its comments, right? So yes, so there's things like the model quality and model safety, which we kind of talk about, which is like going outside of like those guardrails, which is like what you define in the preamble and stuff like. So there's kind of a model quality thing, which is whole entire like life cycle of the model. But in this instance, you've got like excessive agency, right? So you've got literally just all it is like deep down is like lack of network security infrastructure and API security controls about what can call each other. Like traditional stuff, if you're going to put out an application not even using an LLM, all those controls are really relevant here. It's just you're literally just adding like an NC or a layer on top of your existing stack, which has like controls to do X, Y, Z. Token-based authentication, like ephemeral tokens, like all this kind of stuff still applies. Does that make sense?
No, that's fair. Gotcha.
So in terms of this one, actually the actual mitigation was different from other fixes and vendors and only currently applies to the web application. So when the server returns an image tag with a hyperlink, there is now a ChatGPT client-side call to a validation API before displaying the image. Safe false means it will not render the image. So basically, like the way that OpenAI mitigated this is that they would actually make another call to this, like their own internal API route, and be like, "Is this domain safe? Yes, then do X." Right. One thing. Hence the GIF, like, I don't know if I would immediately try fuzz this, but I mean, yeah. So let's be honest, are these really relevant? Because you've got a remote arbitrary website, and then you've also got like the user browsing to it. It's kind of like there is a bit of a trust boundary that's going on. But kind of ask yourselves, how many times do you visit a website during the day, and do you really validate if it's something like a forum, like what are you actually inspecting a web page? So not saying this is like 0 day, but it still has relevant context, right? Data exfiltration, again, in terms of cross-site scripting. So I'll actually, this one's using Google Bard, and I made a little GIF. I thought it was a lot better than an image. So what you can see here is basically Bard is now integrated with Google SaaS, so like Docs, Drive, all that kind of stuff, everything that everyone stores all their secrets on. Prompt injection is triggered when the victim searches or interacts with a document using Bard. The document includes a well-designed payload, which is indirect prompt injection again. Prompting Bard to create a HTML image tag directly to the attacker's server, in this case hosted on Google Apps Script. So the mitigation against the private vulnerability that I showed you before is not relevant here, because in terms of like a CSP and limiting trusted domains, very cleverly actually hosted on Google Apps Script, which is a Google domain. So I actually really like that. It's really cool. Which is actually googleusercontent.com, which is therefore implicitly trusted by a CSP. So really quick on in terms of like mitigation methods. Honestly, the first thing is like human in the loop. We talk about like security through transparency and context. Majority of these things, obviously excessive agency, but if it was transparent to the user what is actually going on, then a lot of this would be mitigated, right? Again, implicit trust, regular red teaming, application security reviews, and then isolation, kernel LLM and sandbox LLMs. I haven't talked about like code interpreters or anything yet, but again, traditional network infrastructure controls, are you air gapping, cloud projects, tenants, applying things like container security policies, however you're running it, all super relevant, right? Quick example of what code injection looks like in NLP code. So you've got an open source framework, which is LangChain, which is basically designed to simplify the creation of applications using LLMs. It's like it's really well adopted by application developers who just want to integrate models and use like an easy framework. Chains are what you get by connecting one model to another. PalChain, which is the function here, reads complex math problems, but often offloads a solution step to a runtime, such as a Python interpreter. So by basically exploiting this, the attacker can execute a prompt injection to laterally move outside of the Python environment, embed, store malicious scripts, or alternatively run malicious scripts, remote code execution. Effectively, you've got like full Python environment if you're able to escape that, right? Okay. This one here refers to situations where the models are, so this is excessive agency, sorry, and kind of alludes a bit more what I was talking about earlier. But excessive agency is where the model's granted too much autonomy and there's not enough human in the loop, right? The OpenAI SaaS feature has OpenAI SaaS app has a feature to store memories, which is basically like GPT's way of like remembering things about you. So it stores like maybe variables or inputs from your conversations to like learn about you, right? Really similar kind of deal here. All the attacker's doing is hosting like a remote website with indirect prompt injection, and it's actually then making a call back to that memories route API, which is actually then like deleting and adding memories. So again, like this is completely implicit trusted. Yeah. Not picking on any model provider, by the way. It's just like some of the best write-ups I've seen. How am I doing for time? Okay.
Yeah.
Cool. So talk a quick bit about data poisoning, which is kind of the latter half of what I was wanting to talk about. So manipulation of pre-training data or data involved in fine-tuning or embedding to introduce vulnerabilities, backdoors, or biases. Fine-tuning is a technique for adapting a pre-trained model, machine learning, to new tasks. So you mentioned earlier about like whether you train, like completely retrain, you can take a base model and you can fine-tune it. It's kind of like literally what a custom GPT is doing in a way. You are taking like a base model, providing a certain data set for it to do like a specific task or function or set of functions. That's what fine-tuning is. Poison information may be surfaced in outputs. So once it kind of gets in the training data and it's in the LLM's data, then it's extremely difficult to. It's like needle in a haystack. It's not like just looking through code. Completely black box. The starting point of any machine learning approach is training data, which is simply raw text. And makes a model highly capable, linguistic, gives it real world information, gives it context. Data sets what model is trained on. That information is commonly accessible within model cards. So it's basically like hey, this is what this model has been trained on, and this is what it's good at doing. Whether that's something like multilingual, or whether it's like trained on code or pictures of cats, like whatever. Just like a gray box engagement, knowing more about your target is beneficial to you in terms of like reconnaissance. A bit about direct prompt injection kind of chained onto data poisoning and hallucinations. So the idea of this attack, which is actually a legitimate write-up, is that an attacker is interacting with a model and actually managed to manipulate it and like basically social engineer it, let's say, into understanding and believing that like a fake registry repository is used for like software development. So like something like let's say like forging npm. That is then entered. So the problem here is that is entered into the training data of the model. So again, like input sanitization from the client, we're trusting everything that's coming in from the client and we're putting it in our training data. That is then spat out to user B. In the meantime, the attacker hosts like a malicious registry with a backdoor or something like that, right? Again, it's like suspect package suggestions. These are like literally prime examples where like GPT is recommended Piloter, which is like literally remote code execution, and this is like about 6 years old. So a bit in terms of we have like a bit of a weird anomaly wildcard with the top 10, which is over reliance. I'm personally not a huge fan, but it is still relevant. Basically, just don't trust everything that Gen AI is telling you. And yeah, here's literally the code for Piloter, which is literally RCE, and you can see the release is yanked. I just wanted to highlight this is a great blog. I'll post our slide deck if that's cool in the channel afterwards. There's some decent blogs and stuff in there. But basically, one of my favorite blogs about ending statement for prompt injection is it's an attack that redirects the attention of an LLM away from its intended task onto another task of the attacker's choosing. So I really honestly like to think of it as kind of like social engineering a large language model, if you think about it. It is really honestly how I see things, like in a very basic form. A bit about hallucinations. So hallucinations aren't actually a vulnerability. They're a type of error that can occur in a generative model, which is designed to generate predictive patterns. So it's not a perfect solution, and whilst it will never be perfect, it is to be expected, right? Because the whole point of like the generate part of NLP is it's predictive patterns and analysis and text. So if you throw some text at a GPT and ask it to write you a LinkedIn post, that is what it's doing. Hallucinations can manifest in different ways depending on the type of data generated and the specific characteristics and of the generated model. Again, it's a ongoing challenge. The one thing that I kind of want to make obvious here is that if you like throw in like cat COS into GPT, you will get a response, and you have not got RCE. But that's one of the things that makes it all very super interesting, is in terms of like regression testing as well, right? That is one thing that is like completely wide open with LLM security, because when you have these kind of like data flaws and everything, it's not just like we have simple regression testing in code and version control. It's kind of like complete arbitrary and Wild West, so to speak. Also, again, model cards. For models being trained on like pictures of cats, then most likely it's going to be a hallucination if you get like a remote code execution or something like that, right? It's all contextual. Very simple ideas here. A couple of images that I threw up. So when we talk about data poisoning, training data is mainly so the start of any training data is most commonly from public data sets. So things like archive, if everyone's heard of that, or Common Crawl, which is just literally an archive of the internet as a snapshot. So like, I don't know how many petabytes, but it's ridiculous. It's so big. The problem with that is that it increases our supply chain because we don't know what's in there. We can't trust it. We don't have the integrity of it. We don't know there's loads of like this nasty stuff in there, right? So split view data poisoning. Basically, there's actually a really good research paper from a buddy of mine where he was able to just run a basic script to identify the sites that are actually being pulled from Common Crawl in terms of the archive. Effectively just bought a load of those domains when they went really cheap and they'd expired, then just hosted a bunch of malicious, like bogus content on there, which then therefore affects the model quality because you're training on like poor data, right? Obviously, the problem with stuff like this is that if you're a model provider, you're effectively kind of shooting yourself in the foot as well. But this is kind of stuff that you probably more see from like a nation state or like a true APT. Front running is literally just the same kind of concept, but you're editing a point of data in time. So like anyone on the internet can like edit a Wikipedia file without an account. So if you put in like Charlie Sheen Wikipedia meme into Google, you'll find a load of funny stuff where people have just like edited Wikipedia Charlie Sheen, as an example. Microsoft Tay was a chatbot on Twitter, which was designed to engage and entertain users. Previous chatbots use pre-programmed scripts to respond to prompts, whereas Tay's machine learning algorithm capabilities allowed it to be directly influenced by its conversations. So it basically became like a racist, and effectively the fault was here is that they, similar to what we kind of talked about earlier, is that they were actually training, and the actual input from the user was, in terms of the algorithm, was actually being reflected in the output. So people were just throwing like a load of like hate speech at it, and it was spitting it out to someone else. One last thing really quickly. So there's a really good, we talk about supply chain. Has everyone heard of Hugging Face? Yeah. Hugging Face is like a great place where you can just like find loads of data and loads of models, and it's very easy to run something on inference. They have like an API model. It's kind of like a model and data registry. The problem with that, again, from a security point of view, is that the supply chain. So Hugging Face, not to bad word them or anything like that. Whatever you know what I'm trying to say. Basically, they didn't have very rigorous security controls. Like security to machine learning has only really become a thing since like our industry has blown up over maybe over the past like 14 months, right? Simple stuff like they never had a verification when you actually register an organization. So I could register an organization with McDonald's. I wouldn't even need to use a McDonald's email address. Simple things like that, which means that they're similar to GitHub, which is another problem, that Hugging Face is full of backdoored models and bogus data sets. Again, literally just showing you here that we can't trust these kind of things. So similar to like your SDLC, model registries, all that kind of thing comes into play as well, right? Security and layers. What is it? As of February this year, there was at least 100 instances of malicious AI models which were found on this platform, which can all perform code execution. And that was just from like this one piece of research. So from a detection perspective, you can Yara and SemGrep static analysis rules, DFIR tooling, improving model cards, and also model scanning within CI/CD. So there's a lot of tools now which will actually like scan, similar to like an SBOM. It's called ML bomb, and we'll scan the layers of a model and try and look for things like this. Very similar to SAST. Oh yeah, here we go. So sorry. So they JFrog deployed an advanced scanning system to examine PyTorch and TensorFlow Keras models hosted on Hugging Face. The social instance specifically, they're basically software which is used to write models, create models. Finding 100 with some forms of RCE. Basically, what I'm showing you here is that the Python's pickle modules reduce methods to execute RCE on code execution, upon loading a PyTorch model file, which you'll see here. And basically, these are like the categories of the kinds of vulnerabilities that they found in those models. Simple POC. So this is JFrog. They're loading their model right here. You'll see, use Python to load the model. And what it's actually doing is calculator, code execution. I think that's actually it. We didn't put a question slide on the end. Lol. Thank you.
Any questions?
And I just also would like to add one thing that I forgot to mention that is really important as well: insider threats, and also our group is always discussing how do we fight malicious AI using AI, because it's really important. Human in the loop, but there's just so much we can do as humans, and so we use the potential of the technology to fight them back. And also, threat actors are already selling malicious AI on the dark web. So that's just how relevant it is.
Yeah, effectively, yeah, like things like Worm GPT is like taking a base model, like I was saying, and training it on like malicious stuff. So how to write malware, for example. A lot of the things I do at my current job are kind of related. So I use generative AI for like adversarial testing. So if I want to train a model on like actually building malware, which I can then use to implement like Yara rules, improve my seam detection. The one key takeaway is you utilize generative AI, right? As security professionals, we should be looking at how we can elevate our game with this. Yeah. Yes,
buddy. Well, I have a question. Like something interesting that I was thinking about is something just as simple as like, let's say you've got your company, you've deployed a generative AI model within your organization. So you can actually use ChatGPT. Maybe you create like your own instance of a ChatGPT and you've deployed it.
Yeah.
And an employee types in, confidential file A. What are the contents of confidential file A? Something like the confused deputy attack. What technical controls would you recommend that organization put in to prevent like a confused deputy attack within that AI?
Yeah, it's a good question. So I'll give you an example of like something that I built like my own bot for Slack, right? And with that, I use like RAG to hook up Notion, Google Drive and stuff. So again, kind of security in layers, right? So the first thing is like when you're using the OAuth scopes between Slack and Notion, like what permissions are you saying? So there are like certain scopes you can get with token-based authentication or keys, where like GitHub fine-grained tokens, for example, right? Like, are you able to read like public documents, like what folders and structures? That's like the first thing that I would start in terms of that context, where you're giving a model access to some kind of external database. But then it gets really interesting and difficult when you're talking about like if you're hooking up a Postgres and then you've got user-based authentication and it has access. Those are where you need to threat model a lot more and really break it down and see what that level of access is. Does that make sense?
Yeah. Are there like technical controls within the model itself where you say like, oh, if there's certain types of phrases that you're trying to input,
yeah, so
block it?
you can build like so you can do like the most simple way but ineffective is input filtering because it's not scalable. So like just filter on bad stuff. The other way you can do is like classifiers, which is kind of like almost building like a detection rule, but it's more generalistic. Again, it's not foolproof. Those and reinforcement learning are like a few like examples where you basically it's like a risk reward. So you have like a judge model which makes unanimous like yes no whether that decision was good as well. Those are like the main techniques, but I would really emphasize like traditional infrastructure security controls are like so relevant. And
Also integrating compliance frameworks as well, which can trigger some alerts. Those are other techniques that can be used too.
Large enterprises block you from getting external data because it's two ways, right? So you have your data going out as well. So they have their LLMs work on getting their real position, ability to put you inside the box.
Yeah.
That you think you putting something outside.
Makes sense.
It's also it's the same thing. It seems like you need a physical see by yourself happening.
yes, sir.
Yeah, just want to double down on that. When you sort of never build a model done, and this is just like build a mental model as
Yeah,
well.
yeah.
When you responded to the question, you gave the example of you built a RAG and connected to multiple data sources, and you kind of like suggested that using kind of like session information of the authenticated user to then define the scope you would use to retrieve the data. That's what I heard, right?
Yes.
Correct?
Yeah, absolutely.
The model I have in my head is that in between that request being provided in a textual form to your model and the model deciding to make a request down the line, there's my assumption is that there's no kind of like Python code or existing. The model is kind of like making the decision.
Yeah, the model is the model.
So you probably kind of like define the model in such a way that you're like, this is what you do when this happens, right?
Yeah.
That it makes me feel based on the examples you shared that can even be bypassed. So like,
yeah,
what would you then do?
In terms of that, it comes down to model quality. So I feel like you can 90 to 95% of these threats you can mitigate with traditional security controls, but like we talked about things like CSP and stuff are like super relevant. That literally comes down to model quality and model safety. And then a big thing in terms of like chatbots, if you're talking about like web applications, is interpreting, encoding, and rendering certain types of text as well is also super relevant. But yeah, you're right. So you got unstructured natural language as an input instead of like SQL injection, which is structured, and you can escape that. You can parameterize queries, stuff like that. This is like, yeah, you literally once you've got your security controls, then the rest is like model safety, model quality. So therefore, it really comes into like actually like shifting left. Well, I don't really like the term shifting left, but shifting left and actually like making those security decisions in the design phase to actually identify and quantify risk and be like, okay, like like kind of the strike table, like this is what we can do, but this is the residual risk.
Follow up. It makes me question what QA or kind of like testing the outcome of a model looks like. I've never like read up on data model. Is that something you can talk about? Like you build a model, how do you validate that it will do what it was designed to do?
So it's a really interesting concept, right? Because it's not like a traditional security architecture review where you've got like a new endpoint and you like, let's say you use the OWASP API top 10 and you check it, you get it pen tested, and it's like, yeah, I think it's good. there's so many different factors that you will never have that full integrity and confidence. So it's almost like sometimes like a ticking time bomb. It's an awful thing to admit, but the current state of things, you don't have like a guarantee. And like I said it like a few times, but regression testing, how the hell do you regression test something that could be a hallucination? How do you verify hallucinations? Like it's all literally like a
And they try to do that in sandboxing environment before deploying. Those are some of the things that developers do before deploying, trying to exhaust possibilities. But you can't, as he said, you can't.
The best approach is red teaming, which is like what we do, and utilizing like AI itself to red team is gonna give you a broader spectrum and a bit more integrity and a bit more confidence, but there is still always an element. There's still always going to be a residual risk, I guess.
So one thing that you mentioned was using LLMs as guardrails. So I've seen where I work, we have models trained specifically to find users trying to abuse the system, and those models are placed in front of like Claude or OpenAI. How have you seen that used from your red teaming experience?
So like I think you're talking about like the Kira guard and like LM guard and stuff like that.
AWS guardrails stuff.
Yeah, stuff like that. Basically, again, there's always different types of. You constantly playing like a cat and mouse game because you've got like red team versus blue team. Effectively, you're just coming up with new and dynamic ways of like security testing. So, I guess. It's a bad answer, I'm sorry, but as a kind of like the defense shifts, then you just shift your offensive mindset, right? And that's where like generative AI and red teaming really comes in handy because it improves creativity, like quantifies your spectrum of testing. I haven't had much experience with like red teaming an application that has specific stuff in. There's things like it all depends on the context as well, right? Because there's like Llama Guard, for example. But if you actually look at the data set of Llama Guard, my personal opinion is that the data set it was trained on wasn't very vast. I mean, it was like developed by Meta, which like I don't expect it to have code execution because it's like looking at data that's from stuff like Facebook as well, right? So I don't have experience with like AWS or anything like that, to be honest. But...
Any other questions?
It's scary.
It's good fun, man.
Yeah. So for large enterprise, right, who are scared, I'm not the only one who is scared. Like they always, we have this, like demand. Hey guys, we want to have some LLMs deployed in our local environment safely, not communicating with the outside world. Still, they're scared, right? So,
yeah.
What kind of advice, like you would give to senior executives? How do they start in terms of strategy?
So it's a good deal. So, good idea. So we have this nice shiny thing called the OWASP Top 10 for LLM Apps. Okay. First thing in terms of like CISOs, like honestly the project is aimed at the wider audience and it's not meant to be a deep dive because it is meant to be like educating at the surface. The best way to like be on top of things, I guess, if that's what I'm going to call it, is like integrate into the topics and really like your basic security fundamentals of things like secure engineering, threat modeling, and really like understanding the context about what you're adding to your application stack is like super relevant. When we talk about red teaming, in terms of like AI, we're not talking about like traditional software developers or security engineers, increasing stakeholders from multiple departments as well, right? So like machine learning engineers and things like that, fostering that kind of like relationship between the company is super key. So like a lot of the most successful red team teams I've seen are like built up of machine learning engineers, AppSec engineers, security operations engineers, like it's getting that like diverse kind of space, which is not like traditional in like application security, right? Like most people are a developer or like they just got into AppSec and they're almost like a developer. It's just like totally kind of different.
Well, all of these guys in the same room, right? And we just let them talk.
Yeah,
requirements.
yeah. Because each introduced their own like unique and vulnerabilities. Like I kind of was trying to allude to earlier. Like a lot of these vulnerabilities they cross over, but then they also have their own unique stance. So the ways you can apply mitigations are like at the model layer, the AppSec layer, network security, infrastructure controls, cloud, stuff like that. But there's a bunch of frameworks. Like honestly, like, I'm joking, but the OWASP is just like a stopgap. MITRE Atlas is pretty good. It's just very verbose. It's quite a lot of information. Depends on like who your audience is. And for like anyone in the room who's interested, like on the OWASP page, we have like a wiki, and I started like a CTF page. So it just literally has like a bunch of LLM application CTFs. So if anyone wants to like get hands on with it.
Protect AI also has their bounty program, which is very nice. They show an example of some artifacts and how to guide. You can play around.
Yeah.
Deep Learning has a nice AI red teaming course, which is also something nice to look at it. We can post on our Slack channel as well for everyone.
What's your Slack channel name?
Oh, so mine's this hideous name. My name on Slack is I think it's just ads. Ads Dawson.
It's on the first slide.
Yeah. But I'll I need to set myself a reminder. But I'll post it. Is everyone in the what is our Slack group called?
I think it's just Austrana, right?
Yeah.
Slack.
If
it's
you haven't,
brand new.
If you haven't yet, go onto the Slack OWASP workspace. You do not need an OWASP account to actually access that. So don't like hit it and then think you need to pay for an OWASP membership because you don't. Go to the OWASP Slack channel. OWASP Slack workspace, which is basically a tenant. Search for OWASP Toronto, and then join. And I'll set myself a reminder to post the slides tomorrow. And if anyone wants to chat, then
Yeah. Here's the ads details.
I think if you go to the first slide, there's both.
I think it's.
And again, thank you Yuki and Ophelia and Adam and especially Jessica and Okta for hosting us tonight. It was great coming. Thank you everyone for your attention and to listening to us a little bit.
Sure.
To share about the project. It's a work in progress, and as we all know, top 10 is only 10. There's so much more vulnerabilities as well. But we're working really hard. We have a great team that are trying to bring what is more relevant to you all.
Yeah, thank you. And honestly, if anyone wants to get involved in like the LLM AppSec project, it's again just literally another channel in the OWASP Slack workspace called Project Top 10 LLM something. Just search for LLM, you'll find it.
Yeah, and thank you guys for the awesome presentation.
Thank you.
And thank you to Jessica for hosting. Very lovely. Thank you so much. And Okta for sure. You had an announcement?
Yes, just for the new folks because I know we have a lot of people, so if you can borrow your computer.
Yeah, sure.
Oh, wow.
Okay. Force of habit.
Please work. Hello. Computing is very hard. Which side is this?
Sorry, anyway.
No, it's a me problem.
It's not you, it's me.
No, it's
We lost connection, but